Ladies and gentlemen, welcome back at the EU Pavilion, and we are going to dive now into the importance of critical raw materials for our global clean energy transition. We have an amazing team of very distinguished panelists for you this afternoon, and before I introduce them to you, I will give you a few words of introduction. Of course, we have been focusing a lot about the importance of the clean energy transition and the need to accelerate. But as we move into the energy transition, this is also a material transition. And this is why it's so important that in this session, we will focus also on the demand for materials and the supply challenges that we have for that. So we are bringing together key stakeholders, policymakers, and experts, and we will really focus on the importance of securing sustainably the management and supply of critical raw materials. In our discussion here today, we will be focusing on international collaboration, technological innovations, but also the need for effective regulatory frameworks in order to secure a sustainable supply of critical raw materials. In the European Union, we have the Critical Raw Materials Act that is focusing on establishing a diversified, secure and sustainable supply of critical raw materials for Europe. At international level, we have the Innovation Community on Energies for Materials on the mission innovation, and these are just two examples of initiatives that we will be focusing on this afternoon. It is really my big pleasure now to introduce to you the panelists that we have. But before we do this, let's quickly wake up the audience that we have both here in Dubai at the EU Pavilion, but also online with us. So I would like to start with a Slido question. So this is an opportunity to look at your phones and not give the impression that you're actually doing something else. So please get out your mobile phones. If we can have the QR code, thank you, also visibly available. So please connect to our Slido and share with us what, in your opinion, can help to increase the cooperation on critical raw materials. So I invite you all to indeed type your responses. But as you are doing this, I'm going to go back to our panelists. And I would like on screen to see also our online panelists, because I would like to start with Dr. Janus Potočnik, who probably does not need any introduction. Mr. Potočnik has been a very influential figure and still is a very influential figure in the Brussels bubble, but also globally, as former Commissioner for Research and Innovation, former Commissioner for the Environment, and a long list of achievements, and currently co-chair of the International Research panel. Mr. Potočnik, a warm welcome. We are extremely pleased to have you here. And I would like to kick off with you to really learn from you, given your expertise, how important are critical raw materials for the energy transition? The floor is yours.
Hi, Rosalinde. Hi, dear friends. Reaching net zero GHG emissions is a global priority in the fight against climate change. And the energy transition is obviously essential. Scaling supply of key materials for the energy transition is a new challenge, but metal ore extraction has already tripled since 1970 in the last 50 years and accounts for approximately 8% of GHG emissions. So we should not lose sight of the overall objective, delivering human well-being within planetary boundaries. That means decoupling human well-being from all resource use. Myself and my fellow IRP co-chair Isabella Teixeira are about to publish an opinion piece on exactly this topic. In Europe, the topic is known as critical raw materials. We rather call it in a paper transition materials. Of course, we highlight the need for improved environmental and social governance. Of course, we talk about improving transition material circularity, but most important, we point attention to mitigating the underlying drivers of transition materials demand. The overall goal is reducing the amount of transition materials needed for energy transition by providing our well-being through reduced material and energy demand, in particular in resource-intensive systems like mobility, housing, nutrition, well-being can be delivered to society with less energy and fewer materials overall. Materials include everything extracted from the earth. We can improve overall energy transition feasibility by optimizing material and energy intensive systems which deliver our basic needs. According to IRP's upcoming Global Resource Outlook 2024, we can do this and raise well-being at the same time. Optimizing these systems could reduce global energy demand by around 25% by 2060 compared to current levels. Managing energy demand will, of course, reduce dependence on transition materials, therefore improving also societal resilience. Meanwhile, as mentioned, we must use circular economy strategies for transition materials directly. This already attracts policy attention. We absolutely need to maximize value and function for each extracted transition material unit across the whole value chain. For example, currently only 1% of lithium is recycled. There is a great potential to design technologies for recycling, capturing more secondary supply. However, it will take time for secondary transition materials to make up a significant proportion of total future transition material demand. In particular, since the needs of these transitional materials are growing. So we must introduce all options to optimize future secondary supply, but we should be aware that in short and midterm, this will not meet a large proportion of our demand. Finally, we need to supply additional needed transition materials with highest environmental and social standards. No universal standard for transparency exists at the moment. Value capture should also be made fairer. Global Resource Outlook results show that only a small proportion of value is currently captured in material extracting countries. But incoming investment can bring development opportunities which should be capitalized. To summarize, the current policies, which are mostly related to securing the supply, are important. But to make sustainability, including energy transition, successful, it is essential to redesign our current wasteful economic system in a way to meet human needs by using less energy and less materials. This way, we can maybe also avoid some energy transition related dilemmas linked to sometimes costly and polarizing solutions. And this would deserve more attention of policymakers. Back to you, Rosalinde.
Thank you so much, Janus. That was extremely interesting, and also thank you for renaming to transition materials. I think that is really very, very important, and highlighting, of course, the need to be more efficient and circular. So it's now my big pleasure to go to Piotr Zimanski, who is Director of Energy, Mobility and Climate in the Joint Research Center of the European Commission, also with us online today. Piotr, welcome. I know that you are a physicist, Piotr, and that you love classical music, but you also now extending your interests and also now look at ballet performances. So I don't know whether you want to dance during your opening statements or not. But in any case, we are really very, very interested, given your expertise, how important are the critical raw materials or transition materials for the clean energy transition. So, Piotr, the floor is yours.
Thanks very much. Good afternoon. Okay. Ladies and gentlemen, Rosalinde mentioned that interesting ballet, but really what happened that I attended the live ballet performance for the first time not long time ago. But Rosalinde would be interested to know that this was the performance called Beethoven and the Dutch School. So that was real pleasure. Now, coming back to the raw materials, Rosalinde mentioned that energy transition is a materials transition. And in order to combat climate change and access secure and affordable energy for our citizens and economy, we need to rely on the massive deployment of clean energy technologies. This includes solar PV, wind turbines, and hydrogen electrolyzers. And it includes the extensive use of batteries for storage and the electrification of transport, So while the conventional energy systems are based on the use of steel and fossil fuels, clean energy technologies rely on critical minerals and materials. Because to build wind turbines, for example, we need rare earth elements like neodymium for the permanent magnets of electric generators. In fact, an offshore wind farm requires 9 times more critical mineral resources than the gas-fired plant on the similar capacity. And typical electric car uses 6 times more critical materials than the conventional. But the good news is that whereas fossil fuel systems consume fuels every time they are used, the materials in a clean energy system remain intact and then can be recovered and reused for at the end of the installation's life, for the new installations, for the new devices. So the challenge is big in the short term, but in the long term, this is how we make our economy sustainable. So if we want the energy transition to succeed, and it must succeed, we need more sustainable energy system. We need undisrupted access to critical raw materials. We need this access not just that we can ensure sustainability, but also to safeguard our decarbonization targets from any further disruptive events. Thank you.
Thank you very much, Piotr. Let's for 1 second also see if you have been able to influence our audience who is still filling in their responses on Slido. So if we can quickly pull up the current Slido poll results. Thank you for that. So we see here the importance of transparency, which I also heard Janis Potočnik refer to. Knowledge sharing, which surely appeals to Piotr from the Joint Research Center. So stay tuned, because we are now moving to our next panelists. So the Slido poll can still change, also depending on how influential our panelists will be in convincing the audience. So it's my big pleasure now to move to IRENA, to you, Roland. You are director at the IRENA for Innovation and Technology Center. And I also know that you started in a nuclear utility many years ago. Then you worked in the oil and gas industry, but I think you understood that you wanted to change a bit the trajectory. So great to have you in IRENA today. And now the floor is yours. So how important are critical raw materials for the energy transition?
Thank you. Thank you very much for this nice introduction, Rosalinde. Also, good evening here to the audience. I would like to make the case of the World Energy Transition Outlook of IRENA, which basically proposed the tripling of the global renewable energy capacity. And let's say, what does this mean for the situation of critical materials? So, for example, we estimate the global demand for EV batteries to reach 5 terawatt hours per year by 2030 in our veto, in the 1.5 degrees scenarios. This is an order of magnitude of growth by 10 times. So in a matter of a decade only, 10 times increasing in a matter of a decade. Onshore wind capacity would need to reach 7,800 gigawatt and offshore wind by 2,500 gigawatt till 2050. This is an enormous challenge. In the case of onshore wind, this is a 20-fold increase compared to 2020 levels. IRENA analysis shows that the availability of materials is not a long-term showstopper. So in the long term, it will be fine, but for the energy transition, with a couple of caveats. So resources are there, but the question is the pace of which these materials can be extracted and processed. If we do not scale production at the pace the demand is developing, so you can imagine the demand is now extremely increasing, while opening new mines takes about 10 years. we could see some constraints in the short to medium term that could slow down the transition. Resources are sufficient globally, but because these materials are in some cases concentrated in a handful of jurisdictions, this can raise security of supply concerns in other jurisdictions. Recognize that scaling material sourcing and processing at the pace is required will be a serious challenge. At the same time, we also think that we systematically underestimate the potential of role of innovation that reduces the dependency on specific materials. So specifically we in the Innovation and Technology Center of IRENA, we see there is a lot of power in innovation to replace and substitute critical materials. For instance, the demand for cobalt and nickel for EV batteries only 5 years ago, LFP batteries, which do not require cobalt or nickel, had a single-figure market share of 0, below a little bit more than 0, something. Now they are approaching already 40% of the global market share because of this challenge with cobalt. Similar promising technological developments that could significantly reduce the demand pressure on some other so-called critical materials. Reduce the graphite demand with increasing use of silicon anodes, reduce lithium demand with sodium-ion batteries, or eliminate the need for rare earths in magnets in generators. So innovation to replace materials and find ways to need less of these critical materials is a key innovation. So innovation is a core part of the solution to challenge to the challenge of critical materials. Furthermore, recycling and reuse or circularity of critical materials is important for two more main reasons. Helps to reduce the negative social, health and environmental impacts associated with mining and improper final disposal, and it also helps to decelerate the depletion of natural resources. This helps to reduce the demand for raw materials, minimizes the dependency on material imports, and unlocks new domestic value streams and job opportunities, and may also reduce the technology cost. So globally, the implementation of reuse and recycling is still in the early stages. We need functioning, sustainable reuse and recycling ecosystems, as they have been addressed also by the European Union in their legislation. I would stop here. Thank you.
Thank you so much, Roland, and also for providing us some facts and figures, and for underlining the importance of sustainability, circularity, substitution, and of course, again, efficiency. So I'm thinking that there's quite some agreement also among our panelists. Let's see whether Christine maybe can bring some alternative views. So Christine, welcome. Christine is the director of the German Federal Ministry for Economic Affairs and Energy. And I also understand that, Christine, when you're not working for the ministry, we can find you on your bike. And it's also a very efficient way, I'm told, that you're taking meetings from your motorbike. So when you are on the German highways going very fast, still having meetings is a very efficient way of dealing with time. So I'm very curious to hear your perspective on the role of critical raw materials for the clean energy transition. And yeah, you can pretend to be on your motorbike when you do your intervention.
Yeah, thank you very much for this. Of course, when I'm going very fast, then I don't have any meetings. Only when I'm going slow through the beautiful landscapes of Brandenburg, then I have the meetings. But anyway, I just wanted to maybe zoom out a little bit, because in my capacity at the ministry right now, I'm coordinating the market ramp-up policies for hydrogen. So this is my topic, and there, of course, critical raw materials, the question of market ramp-up and what materials do we need for the energy transition, especially in this field, is a topic that we are dealing with on a more or less everyday basis. Innovation plays a very strong role. But I just wanted to zoom out because I wanted to point to a very important aspect that we need to think about when we design our policies, not only thinking about raw materials, but also in the broader picture. a market ramp-up typically is done through scaling. Scaling production, we want to have the cost curves down, we want to have larger facilities, we want to have simple technologies in order to be able to bring the costs down and in order to have lots of electrolyzers, lots of windmills, you know, scale. However, this can be in competition with the goal of diversification, which is, as we know, super important, and it's also super important when we look for the use of new raw materials, of alternative raw materials, when we want to reduce our dependency on certain critical raw materials. So I think it's very important that we, in our strive to diversify and also to think about the efficient use of our material policy or raw material policy, that we also always keep in mind the bigger picture that we have, and that we really need to think about timelines and sequences of when to use which materials, how to deploy what we have, and also to think about alternatives early enough in order to make sure that the market ramp up of in our energy transition, hydrogen is only one example, is being taken care of in the whole and broad range. So what can we do to make sure that we reach both goals at the same time? Diversification was mentioned a lot. Not to forget about scale. We can diversify regionally, of course, and that was mentioned before. We can diversify towards technology, and when we think about technology, a very important aspect, of course, is the question of alternatives and innovation. And I want to come back to the picture that you had with the words and what is most important for the audience in the background. And two things were there. One was transparency, and one is knowledge sharing. And sorry, I can't really bring any controversy into this, because knowledge sharing and transparency is, in the scientific field, the thing to be innovative as much as possible. Of course, there's funds, and I also saw funds in the word cloud, but there's only so and so much that you can do with money. International exchange, national exchange, of course, of the different scientific communities is super important, and I think there are a lot of new ideas also out there to bring people together, get them around the table, get them to exchange, use platform, use digital solutions, database, and we might talk about that a little bit later as well. But I think this is very important to also connect and to make sure that we share the knowledge that we have in order to achieve this common goal that we have.
Excellent. Thank you so much, Christine, also for zooming out a bit. And your reference to knowledge and innovation makes a nice segue to our last but not least speaker, Adel El-Gamal. He is the Secretary General of the European Energy Research Alliance or Association, or something that starts with an A. You will be able to correct me. You will be able to connect me, which in the Brussels bubble is known as ERA. So, Adele, before I give you your 3 minutes of opening remarks on the issue, I want to share with the audience also something that people don't know about you, and that is that you apparently are colorblind, so you are a bit worried whether the outfit that you're wearing today actually matches together. So we can reassure you.
I took a grey one.
Oh, grey works. Okay, very, very good. So I hope that you will not be presenting us any colored curves and statistics there. But very curious to get your take on the role of critical raw materials for the energy transition.
Thank you very much, Rosalinde. And I will be, in fact, very short for the sake of timing, because I think we are running late, but more importantly, because I think most of the points I wanted to discuss were already mentioned. And I would like maybe to just to come back on 3 points. And the first point I was going to mention is in fact the first point that Mr. Potočnik has mentioned. The fact that if we think about the the global target that we're aiming to, it's sustainability. And when we think about the enormous amount of transition material that will be needed to achieve the net zero according to all scenarios, we have really a problem in terms of decoupling. And so our take is that it is absolutely essential, as we are unable to decarbonize the supply side sufficiently rapidly, it is absolutely essential to take a very, very hard look at how to decarbonize the demand side. And this is looking at demand reduction strategies that should be embedded at the core of the clean energy transition policy making. And when we're talking about demand reduction strategies, is not necessarily the same as talking about degrowth. It's about really taking a hard look at concepts such as energy sufficiency, which is basically giving the same level of comfort with different energy services and less energy intensive services. So this is absolutely fundamental. And this is, by the way, one of the main research topics on which we delivered a report at the high-level policy conference we had a month ago in Brussels. Fundamental to look at the demand side and reduce the demand. Now, looking into the how do we get still these critical raw materials, I will not come back to what was mentioned earlier. We know the figures, we know the dependencies, we know the Critical Raw Materials Act from the Commission, which really acknowledges the complexity and the urgency of this matter. I would just like to point out two things. First one is the fact that it will be extremely difficult to get any significant production of critical raw materials in Europe. And the reasons are multiple. One is because the size of the available deposits. The second is the societal acceptance of it. And this will be a major, major obstacle in Europe. And the third one is the competitiveness. Well, the third one is competitiveness. And the fourth one is also the cycle time that would be needed to really get these critical raw materials online from our production. Then comes the question of diversifying the supply chain, the imports, through managing the interdependencies. And I would like here just to recall that we are in a very, very different world than the one we knew even a couple of years ago. We are not anymore in a world of open trade, of multilateral negotiations. We are in a very fastly shifting geopolitical order. And in this perspective, we need to understand that these import dependencies become really risk in terms of security of supply. And I would just mention one thing. If we look at lithium, rare earths, cobalt, and nickel, it's not only that China is owning or controlling the mines, it's that they are leading and in some cases have a monopoly on the processing of these materials. And probably some of you know that as we speak, Ursula von der Leyen and Charles Michel are having a high-level discussion with Xi Jinping, which I think will be a quite thorny discussion, discussing about support to Russia with dual-use imports, discussing about the Baltic pipeline, and discussing about trade competition and trade deficit. So this is the world in which we are, and which shows that the strategic autonomy of Europe is really at stake. So again, we need to reduce demand very significantly, and we need really to look deeply into research on how we can have better material efficiency and substitute critical materials to reduce our reliance on these imports.
Beautiful. Thank you so much, Adel. And that is a nice bridge back to Yannis. So, I mean, listening to what's happening in the international community, how do you see international collaborations evolving, and what are your expectations to make sure that we do not only address the supply challenges, but also that we deliver on environmental and also social sustainability?
Yeah, thanks, Rosalinde. Actually, I would just once more underline everything what Adele at the end was saying. So we don't really, so we need to understand that this is an excellent opportunity, that we put the attention to the importance of resource management also in the energy community, because this was to a large extent now missing. But I was, as Environment Commissioner, always a bit worried, to say it mildly, when we started to talk about the critical material needs, because this is pretty much an economic view and not about better management of all materials, which is basically very much taking into account also environmental impact. And we know that we are already crossing the planetary boundaries. So delivering human needs by using less energy and materials, it's critical if we want to look at the bigger picture. But you're asking me also about these questions. By the way, I should, in the opinion piece which I was mentioning, we are basically mentioning quite a number of issues, how one can proceed. We believe that in mitigating the underlying drivers of these transitional materials and the demand, we need to institutionalize resource management solutions, give a clear mandate to science to develop resource use targets, so to reduce the overall material and energy demand through efficient housing, mobility, food systems, all the systems which are basically resource intensive. So national policymakers should plan for absolute and relative decoupling depending on their level of current resource use and their requirements to meet essential human needs. On operationalizing the transitional material circularity levers, as mentioned, we have quite a lot of reserves there too. We need to, for example, in the case of batteries, we need to overcome the barriers which are currently existing. Countries can work together on standardization, on improving battery recycling economic viability, for example, by initiating a dedicated task force with industry and societies. And finally, the international community needs to agree on operationating standards which ensure mining is aligned with sustainable development. In the IRP, we are recommending something which we are calling a sustainable development license to operate, the SDLO. Transparency is crucial for the successful implementation, and we need mandatory disclosure and monitoring of transparency in transition materials value chains. So we need enough for immediate actions, but priorities can still be refined through scientific work, in particular modeling, which should be supported also in the future. So lastly, the thing which I would like to say is energy transition should not be looked and addressed in isolation. So decoupling resource use, including transition materials, is essential for living well within the planetary boundaries. Thus, we should not focus only on those materials which are in energy transition, but on all for which we are currently not managing sustainably. We should stop stimulating extraction-based economic success and reward responsible, innovative, creative ways of meeting human needs. So, in short, the future will be green, or there will be no future.
Thank you so much, Janus, for these inspirational words. We are very much looking forward also to the opinion piece, so we will stay tuned for that one as well. Let me quickly go back to Piotr, because JRC is developing an evidence base, and JRC published a report on critical raw materials. I would like to ask you, Piotr, to focus on the 3 key messages, and I will be strict with you here, 3 key messages that you think are the most important ones that come out of this latest JRC report on critical raw materials.
Thanks very much, Rosalinda. With science, it's a bit difficult because science does not go in group of threes. So I will just tell you a few words about our foresight report, which was published alongside the critical raw materials, which we analyzed the complete supply chain for all key clean energy technologies. So we forecast the material demand, we assessed dependencies in supply, and we also looked at the measures to reduce these dependencies. So we learned, we tell you and policymakers that the demand will shoot up in connection with Europe Repower EU. It's no-brainer, but we estimate how much it will shoot up, and this would be huge increase. There will be also massive competition, not just between the regions, but also between the industrial sectors for some critical resources, wind turbines and electric vehicles, but also data servers, particularly in the times of artificial intelligence and electronic devices. Now, already we heard that the extraction processing is concentrated, so this is a huge risk of disruption. And last is that we identified materials strategic for each technology according to the definition in the Act. And since I was told to be short, let me finish here. Thank you.
Perfect. Thank you so much, Piotr. And I think at least I see some people in the audience that are now grabbing their phone to look for this foresight report from JRC. So also all the other messages, I'm sure, will be landing as well. I'll be moving now to Roland. And I would like to ask you, Roland, to say a few words and really, again, 3 sentences on the IRENA's collaborative framework for critical materials and the energy transition. So make the people curious, don't say too much, and then I'm sure everybody will also check out IRENA's collaborative framework.
Thank you, Rosalinde. The collaborative framework is a dialogue with the private sector that IRENA has outside the institutional formal setup of the organization that gives IRENA stakeholders, let's say private sector associations, also companies from member countries, the possibility to have a dialogue with policymakers about certain topics. And there we have several. One is the one on critical materials. On critical materials, we can kind of had 4 sessions. There is always 2 chairs from the member countries, and we launched this collaborative framework on critical materials in 2022. And since that first kind of meeting to set up the collaborative framework, we have had 3 additional thematic meetings, one on strategy to de-risk the supply, an additional meeting around the issue of data collection to monitor potential supply shortages, and the 3rd meeting with a focus on environmental and social governance aspects of mining.
Okay,
and
thank
that's
you,
a good
Laurent.
thing. It brings a good idea of what is needed, let's say, from the private sector, and what can policymakers do, and they can bring it back into the formal discussion at IRENA. Thank you.
Excellent. Thank you so much for this collaborative framework. And speaking of policymakers, Adele, if I could ask you, if you could ask one thing to the policymakers, what should the policymakers focus on?
I cannot answer you with one, but I can try to answer to the question very briefly. And thank you for the question. And I would like also to mention that in this policy conference we had a month ago on demand reduction, there was also another research study, which was a report on critical raw materials for low carbon technology, which is available on our website, and which I believe will be very complementary of the one of GRC, where we're looking at the 5 key technologies, which are wind, solar, hydrogen, power electronics, and electrolyzers, which are really key to the transition. And so basically, we see how research could help in 3 respects, not one. The first, of course, is recyclability, and in that respect, there's a notion, of course, of design, recycling by design, but there's also much we can do with recycling, much more than one usually think, which is very, very much embedded in the concept of the hour ladder, where you have 9 different strategies to recycle. So that's one first element. More importantly, I think there's a very important element, which is material efficiency, consuming less material for delivering the service or the function that we want. And thirdly, there's the question of material substitution, which is fundamental, of course, as well. What I would like to mention in terms of policy making is that these research areas, in fact, they span across the TRL range. So you have basic material research, but you have also research which must be done at the higher TRL level. And so it's really fundamental that this is really understood by the policymaker and well taken into consideration in terms of how it is funded and supported financially.
Very good, Adel. Thank you so much. So from the work of ERA, we now go to Christine, and I would like to ask you, because you're co-leading on the innovation community of materials for energy in mission innovation. Can you just in 3 words say, why this is such an important innovation community and why more countries and companies should actually join this community?
It's not possible in 3 words, but anyway, I will give you the link to the platform, which is, if you want to look it up, it's M4, the number 4, and then E. And if you look through the platform, you will find all the reasons you need. It's a platform to connect. It's an initiative between Germany and Canada and many others. It's a platform to connect the innovative community, the scientific community, in order to exchange. And I mentioned it before, I think this is a very important first step. The second step you can find there also is our initiative there for material acceleration platforms. That's the database that I mentioned before. So there we are also exchanging information on scientific projects and open up for an acceleration through cooperation and also through funding, of course. So I'll leave you to this and to look this up. And if you need more information, feel free also to reach out to us.
Thank you so much, Christine. I think this has been extremely inspiring as a discussion, and also lots of homework for the people here and for the audience. So I think we need to stay tuned for the opinion piece that Jannes referred to. We will all dive into the work that the JRC has been doing on critical raw materials, including foresight. Then, of course, we need to check out the collaboration forum of IRENA to look into the research and the reports published by ERA, and last but not least, also look into the innovation community M4E, or Materials for Energy of Mission Innovation. To conclude, let's just see again the results from our Slido word cloud to see if there have been any changes there. Does not seem to be the case. But still, thank you also to the audience for an active participation. I think the last word has not been said on the use of critical raw materials for the energy transition. What I take away from the discussion in terms of just keywords is that we need to look into all aspects of the sustainability, so not only the economic aspects of the critical raw materials, but also the environmental aspects and the social aspects, and that we need to focus not only on substitution, but also on circularity and efficiency. So I would like to thank you very much starting with our esteemed panelists, and let's give them a very big and warm applause. Thank you so much. Then for the colleagues who are here in Dubai, before you start checking out all the reports and initiatives that we discussed here in this panel, we are offering a drink in our EU pavilion, and you're all kindly invited to join us for this drink where we can continue to discuss. And for the people online, sorry, but have a drink on behalf of us, and stay tuned for more very exciting events at COP. Thank you very much.
Thank you.